Morning to all. Today we are discuss about Unit 4 PSA 1. Develop the expression for analyzing double line to ground fault in a large power system using Eject bus matrix. Consider a fault between phases B and C through an fault impedance to ground at bus K as shown in figure. A bus K of network ABC. B and C connected with the fault impedance into the ground. Double line to ground fault at bus K. The phase A sequence network of figure applicable here, where the positive sequence impedance is placed in series with the parallel combination of the negative and zero sequence networks. The symmetrical component of the fault current as IK1 is equal to VK0 divided by ZKK1 plus ZKK2 into Z0 plus 3ZF divided by ZKK plus ZKK plus 3ZF. The next one, IK power 2 is equal to minus VK0 minus ZKK1 IK1 divided by ZKK power 2. Then IK power 0 is equal to minus VK0 minus Z1 KK into IK divided by ZKK plus 3ZF, where ZKK1 and ZKK2 and ZKK0 are diagonal elements in the K axis of corresponding bus impedance matrix. These phase currents and the fault currents are IKF is equal to IKP plus IKC. The next, derive the necessary equation for calculating the fault current and bus voltage for a single line to ground fault. Figure illustrates a three-phase generator with the neutral grounded through impedance Zn. In this connection, star connected, IA is the current value, then another one is the IB, and IB is equal to 0, IC is equal to 0. In this connection, VA connected with the fault impedance in the ground. Suppose line to ground fault occurs on phase A through impedance ZF, assuming the generator is initially on no load. The boundary condition at the fault points are VA is equal to ZF into IA. IB is equal to IC is equal to 0. Substituting the IB is equal to IC is equal to 0, the symmetrical component of currents, then IA 0 power IA 1 power IA 2 power, that is equal to 1 by 3 symmetrical component of the elements equal to the value of matrix in the form 1 1 1, second row 1 A squared, then third row 1 A squared A, and then current value IA 0 0. From the above equation we find that IA0 is equal to IA1 is equal to IA2, that is equal to 1 by 3 IA. Phase voltage in terms of symmetrical component is VA is equal to VA0 plus VA1 plus VA2. For substituting the VA0, VA1, VA2 and nothing IA0, IA1, IA2, we get VA is equal to EA minus Z1, Z power 1 plus Z power 2 plus Z0 into IA0, where Z0 is equal to ZS plus 3Zn. Substituting the VA from nothing and nothing, IA is equal to 3 IA0, we get 3 ZF IA0 is equal to EA minus Z1 plus Z2 plus Z0 plus IA0. Then IA0 is equal to EA divided by Z1 plus Z2 into Z0 plus 3 ZF. That is equal to the fault current IA is equal to 3 IA0 is equal to 3 EA divided by Z1 plus Z2 plus Z0 plus 3 ZF. Substituting for symmetrical component of current, the symmetrical component of voltage and phase voltage at the fault are obtained. In this, three input supply EA plus that is V1 is the V1 is the positive sequence, then V2 is a negative sequence, then VA0 is a zero sequence. In this element, it will be connected to the impedance of Z1, Z2 and Z0. Then total fault impedance in the fault current analysis means 3ZF. That means fault impedance in 3ZF. Next one, problem. A three-phase 10 megavolt ampere 11 kV generated with a solidly earthed neutral point supplies a feeder. The relevant impedance of the generator and feeder in ohm are as below. Generator and feeder. Positive sequence 1.2, J 1.0. Then negative sequence J 0.8 and J 1.0. Zero sequence 0.4 and J 3.0. If the line-to-line fault occurs at the far end of the feeder, calculate the fault current. That is E is equal to 6315 volt. The total impedance Z1 is equal to J 2.2 ohm. Then Z2 is equal to J 1.8 ohm. Then Z3 is equal to J 3.4 ohm. For the line to ground fault, I1 is equal to I2 is equal to I0 equal to minus J 858.10 amps. Then fault current I is equal to 3 into I0, that is equal to minus J 2574.32 amps. The line to line voltage of a phase VA is equal to 4319.6 volt. The next problem. A salient pole generator is rated 20 megavolt ampere, 13.8 kV and has a reactance is equal to 0.25 per unit. Then second reactance 2 is equal to 0.3 per unit and zero sequence reactance is equal to 0.1 per unit. The neutral of the generator is solidly grounded. Compute the fault current in the generator and line to line ground fault at its terminals. Neglect initial load on the generator, the reactance of the generator, then X double dash equal to X2 is equal to 0.15 per unit and reactance is equal to 0.005 per unit. The generated ratings are 10 megavolt ampere, 6 kilovolt. The generator star connected with the neutral point grounded through a reactor 0.5 ohm reactance. Compute the fault current in amps when a single line to ground fault occurs at the generator terminals. Then IA1 is equal to, that means positive sequence is equal to minus J 1.667 per unit. Then IA2 is equal to, that means the negative sequence is equal to minus IA1, that is equal to J 1.667 per unit, and IA is equal to 0. IA is equal to IA0 plus IA1 plus IA2, that is equal to 0 IB is equal to total IA value is equal to minus 2.866 per unit. Then IC is equal to minus IB, that is equal to 2.866 per unit. Base current is equal to 837 amps. Therefore, IA is equal to 0, IB is equal to 2416, then IC is equal to 2416, then line to ground voltages are VAB is equal to 1.749. Then VBC is equal to 0 per unit, then VCA is equal to 1.749 per unit. Thank you.